Yeah, I'm Eric from Semptian. For the first thing, I want to thank NVIDIA and the OpenPOWER Foundation. So now let's get back. Well, for Semptian, there are three main targets in this summit. First, we want to meet the other members of the OPF face to face. And the second, we want to show our achievements in this community. And the third, we are looking for more collaborations, including design houses, API vendors, and the system integrators. Okay. And as we all know that power is really a powerful processor, but the hunger for more computing resources never ends. So as an option, we developed the Accelerator for power. It's based on the FPGA technology from Deng. Okay, and it is a short brief. Who is Semptian? Semptian is founded in 2003, and in the past 12 years, we provide the data acquisition and analysis product for our customers. So most of our customers are requiring accelerating solutions. They always ask for us for a turnkey solution. Okay. And this is our Semptian's NASA Accelerator. Yeah. And it's based on the KP technology from IBM and the AstroScale technology from Xilinx. And I'm sorry, there's something wrong when I change it from the PPT to the PDF. Okay. Now, in the next, I will show some NASA accelerator features. And the first is high performance and low power. And as we all know that, FPGA is born to be a programmable hardware, and it can be tuned down to the gate level. So, so the power consumption of the electricity consumption of the FPGA is very low. You can see that in this slide, we have completed 3 acceleration functions on our NASA card. And all of them has a minimum 10 times speed up, and the electricity is only 1/3 comparing to that of the CPU. And so additional external power is not needed, and no additional air cooling is needed. So you can just plug the card into the PCI slot of a server, and it can work. We have installed it in many servers. In fact, we ever installed 4 NASA cards into a single server for accelerating purpose. And I have to say that the most interesting thing about the NASA is that NASA uses dedicated security chips for the third-party IP protection. As you can see that a unique ID can be written into and stored in the security chip. The ID cannot be read back. So each time when the accelerating function is loaded or called by the software, it can use a ID-related license for validation. If the validation passes, the card can work. If the validation fails, it can refuse to work. So the value of the intellectual property is guaranteed against illegal copy. And we have to say that for an accelerator card to a success, there are still several things should be done well, including business development, experienced and adequate technical support, collaboration with IP vendors, high quality control, and effective delivery. In the past 12 years, Semptian's data acquisition and analysis product has been deployed in all the provinces and the most big cities in China, and also in some countries in Asia and Africa. Most customers have potential needs for accelerating solutions. And in order for a rapid response to customer support, an engineering team of 180 persons are kept, including the people for developing and the pre-sales and post-sales. That is 70% of the total employee. So, and every year, we can see that Semptian delivers more than 10,000 network equipments to customers. Our 12 years experience in hardware design and our robust and resilient supply chain is a good guarantee for a good delivery of high-quality products to our customers. And in the following time, I will show some success stories to use NASA for accelerating purpose. This is Enriched Code. Enriched Code is a kind of data backup method using Real-Solomon algorithm. In fact, it split the original data into several blocks and generated new blocks by calculating. The original and the newly generated blocks together construct a protected data group. If some blocks were missing, the remaining blocks can be calculated and for data recovery without loss. You can see that in our implementation, we will use only 140% storage capacity, contrasting to the traditional HDFS, which will need 300% storage. That means 1/2 reduction in the storage medium. That also means the cost will also reduce to 1/2. But it will pay a huge burden on the CPU, and we can see that by accelerating with NASA card, the Power CPU can implement the Enriched Code in real-time services. And here is another application, image resizing. Image resizing is widely used in many internet services, including online shopping, web surfing, and social media. For example, the image is resized to terminals of different screen size, or the image quality is adjusted to the subscribes level. And we collaborate with ClassTech, a company in Hong Kong, to provide the image resizing implementation. And we can see that the electricity consumption is cut down. So the expense for the cooling and for the electricity consuming is reduced too. Okay, as a conclusion, I have to say that a strong and open ecosystem is essential for OpenPOWER's success. Especially in China, all our customers just want a turnkey solution. Semptian is willing, together with our partners, to discuss with our customer about the performance bottleneck. And Semptian also welcomes collaboration with more design houses and IP vendors. Our booth is number 1013. We'll be happy to meet you there. Thanks for your listening.